we have worked on lipids and myelin like for a couple of years now, and found out that the relevance of lipids for demyelination, remyelination is really target several aspects. So, it starts all out with cholesterol being a rate-limiting component for myelination, and this is during developmental myelination, but also during remyelination. So, one big aspect of our research is to find out where the cholesterol comes from for remyelinated myelin sheaths. And so this is one aspect. Then we and also others like Jerome Hendricks, who was also participating in this session, he and many also other groups really address more the fatty acid part of the demyelination and remyelination, since myelin membranes are not only cholesterol rich but also rich in other fatty acids. And there it turns out that the handling of lipids in microglia is really relevant for the efficacy of repair and also for the efficacy of clearing the myelin debris, which occurs during demyelination. And I think so. What the underlying theme really there is that that the recycling process via microglia is a process which is very relevant and which can be perturbed due to too much myelin at the same time, or disease chronicity, or other environmental factors in the local lesion, which perturbs this recycling process. And this then leads to the accumulation of lipids in microglia, leading to foamy appearing microglia macrophages. And these, we think that these cells are really not actively participating in the repair within the demyelinated and remyelinating lesions. So when the microglia or the phagocytes are kind of taken out of the equation of repair, then the question is who's responsible for repairing the lesions and the lipids, where do they come from? And we have shown in a couple of studies that several cell types contribute to cholesterol synthesis in this respect. So oligodendrocytes themselves, which is quite natural because they also do this during developmental myelination. But surprisingly, also neurons seem to contribute to the local cholesterol by endogenous synthesis, and they seem to also provide this cholesterol to the environment, because we observed that oligodendrocyte precursor cells react to this by proliferation. This is, at least in the cochlear model, very relevant for repair function. This might be a little different in human lesions of MS patients, but really to decipher how much remyelination is mediated by oligodendrocytes or newly formed, the old remyelinating or oligodendrocytes, or newly formed oligodendrocytes from precursor cells, is, I think, in MS lesions not always clear, and might be also depend on the lesion type and, of course, the disease chronicity always. And this, there with mouse models, we have a lot better grip on what is really happening, because, of course, in patients, you have this one spot on autopsy material, and that's it. Lipids and lipid metabolism, as well as cholesterol, have also very relevant effects on immune cell function and activity. This is not our expertise, but this is done by very many groups around the world. And also here it seems that lipid metabolism is very relevant. And then what we found recently, that one aspect of MS and also of the mouse models of remyelination, is that the neurons and the axons within the lesions are damaged, and this is often goes together with especially defects in mitochondria in axons. We have seen this in the EAE or in the Kuprizone model. Many other groups have seen this in the EAE model, but this is also very well known from MS patients, and Inge Göttingen from the Netherlands Brain Bank has also found now that mitochondria in axons of MS patients seem to proliferate. So this are all reactions of the axons to what we say energy deficits, because mitochondria are the power plants of the cell, and when the axons cannot provide themselves with energy or produce the ATP, then also the impulse conduction cannot be maintained. So the energy must come from somewhere, and it seems to be that the carbohydrate metabolism is kind of down-regulated, at least what we found in the EAE model. But also there were studies showing that it's might be similar in MS patients, and we would propose that not increasing the lipids, not increasing the carbohydrates, but increasing the lipids could contribute to replenishing this energy deficit in the CNS, and this might help the beneficial effects of increasing lipids, so increasing, in this case, more the ketone body metabolism for the neurons, which then helps that the damage to the neurons are at least minimized.